Hello, everybody. Welcome back to yet another Octant live stream with some of our Epoch 8 projects. This time, projects building for the Ethereum infrastructure. We have Zoe from Act, Mate from HEVM, and Melson from Samba. Um, yeah, so as usual, gonna start with a quick round of intros. I'm Nico. I'm doing community at Octant, and we are currently in our ninth, actually, funding round, Epoch 8. We had Epoch 0, that's why. Um, and we basically been funding public goods, digital public goods primarily, with staking rewards from Ethereum that the Golem Foundation has staked. And the the focus of this epoch is Ethereum, mainly because we're now building Octant V2, that is a protocol that will help other ecosystems within the Ethereum larger ecosystem to do the same as us, basically use yield to fund their ecosystem growth, their grants programs, their marketing, whatever they feel like it, and at the same time fund what we call the Ethereum Sustainability Fund, that is gonna fund all these Ethereum dependencies and all these crucial things for Ethereum. So that's kind of what we're trying to emulate here a little bit before we launch V2 with Epoch 8. So pretty excited about that. And yeah, that's enough from my side. Would love to start with you, Zoe.
Hi everyone, welcome to this live. I am Zoe. I'm very interested in programming languages and formal verification, and I do research on this area. And I think that Ethereum and blockchain, the blockchain space in general, is a great application domain for formal verification. So I am developing Act, and I will share my screen to give some intro for ACT. So Nico, is this a good time for the demo, or does this come later?
Yeah, absolutely. Feel free to
Okay,
show us. Let me put up
awesome.
your screen share here and go for it.
Mhm. So this is just a high level diagram of what ACT is doing. So ACT is a language, a formal language that can express high level, um, rigorous specification of smart contracts. And then once we have such a specification, what we can do is to automatically prove that the bytecode of a contract adheres to the specification. And this is a low level and messy proof, but it happens automatically using symbolic execution. And what's nice about it is that it is language agnostic. We don't really care about what source language the bytecode comes from. So we have a specification language that can express um, um, what a contract does, and it's independent, it's language agnostic. So once we have such a specification, which basically describes the state transitions that a contract can do, we can do various things with it. We can connect it with verification tools, well-known verification tools like SMT solvers, and interactive program provers like ROC or Lean, or game theoretic analysis frameworks, and we can prove properties about the specification. So ACT is a glue between like the low level bytecode and what it is doing and high level proofs. And the user only needs to care about the high level proofs that are more intuitive, and like it abstracts away of all the nitty gritty low level details that um, are handled in this equivalence proof that's automatic. And I will quickly walk you through an example that's actually substantial. So we have a here in the left of the screen, we have a Solidity implementation of an ERC20 token. And basically it has all of the functionality prescribed by the ERC20 like API. And so you don't need to understand all of the details. It's just like the solidity code of what an ERC token is doing. And on the right, we have the act specification of it. We have written all of the different cases, and this mathematically describes what the contract is doing. Basically, its behavior of the contract is translated to a behavior in the specification that has some preconditions that are the conditions under which the contract terminates, the behavior terminates, and the result, what happens in the storage of the contract. And once we have these two, we can automatically verify that these two like match each other. With by calling act and providing the solidity code and the specification, and that here is exhaustively checks every behavior. It takes about 1 minute in this case, so I will not I will let it here to run in the background. And then what is cool after having the specification is that we can translate it in logic and use every, like we can connect with various verification tools. Here I'm using the ROC backend that translates the act specification into the logic of the ROC proof assistant. And it automatically, everything that you see in the left of the screen is automatically synthesized, automatically extracted from the specification, and it describes all the possible state transitions of the contract. This mathematically captures everything that the contract can do. And it also it generates this predicate over states that characterizes all possible reachable states of this contract. And once we have that, we can prove theorems. And this is the manual part. This we do manually. And this theorem states, for instance, that for every reachable state, the total supply, which is the storage variable of this contract, accurately captures the current balance, the current sum of all balances of the contract. And that was it. Verification here finished. We know that the specification exactly captures the contract, and that's a little walkthrough of ACT.
Amazing. Thank you, Zoe. Super
Thank
cool.
you.
I'm always very impressed by how you can like dig into the mathematics of the smart contracts and like yeah find the magic there, or like how it beautifully works together or doesn't work. So actually, maybe a question quickly: what is a red flag? You know, like how do you identify something that's not working well?
So, I can easily show you. For instance, if here um, I changed something. Let's say here I had an off by one error and did that, then this would fail, and
Hmm.
it would say, "Oh, this is not equivalent anymore." And here is a counterexample.
Okay, awesome. So very simple for us, but probably very heavy in the background. So that's awesome. Love that. Cool. Thank you.
Mhm.
Let's move on to Melson.
Okay, hi everyone. So I'm Nelson. I'm working on Samba. That is a hub-based implementation of a portal client for Ethereum. And Samba we have started working in Samba since last year. And since then, we have been making progress around passing all hype tests. Actually, we have most of all hype tests passing. And yeah, the main function of Samba is that it brings to the community another implementation of a portal client. Then I will get deeper in the actual situation of the network. And this implementation let us get different type of content from Ethereum data. So actually, one of the main endpoints is that you can provide a content key, and through that content key, there could be a block hash. For example, you can get the block header with proof, or you can get the content given the block body hash, or you can also get the receipts through the receipt hash. At the same time, you can get the block header by number. So actually, Samba use as a discovery library. Sorry, Samba used for discovering other nodes in the network. It used this B5, and through this B5, it also send the content, share the content through the other peers. So it's actually an extension of this B5, where once a peer is known to have the content, it open a UTP connection, and through that the content is shared between the nodes. At the same time, this unique implementation let us also run Samba with certain modifications. We are not actually on that, but there's someone also working in a side project where they extend Samba and use it on Android. So with certain modifications, you can run the node on an Android environment. That is something super nice, as it extends the possibility of the usage of this node. And the other important thing is that Samba was designed to be super simple. We're using libraries from Besu and Teku. So this also let us reuse these libraries, and at the same time provide more robust solution as we keep on using things that are already in production. At the same time, we find different bugs sometimes of these libraries. So it's another way of testing these type of libraries. And the current situation of Samba is that we support only history subnetwork. That, as I mentioned, it's enabled decentralized access to historical block headers and body. And since June, the portal network has been reshifted. So there's a situation where the main goal that originally was designed have changed. So we are in a big challenge right now, because as we originally started thinking as a standalone solution that was fully detached from the execution layer, and since the decision of the community was to attach it to the execution layer. So this brings us to new changes to the portal network, and actually each of the nodes. So that might bring to shift the roadmap. So yeah, so we are on that. Yeah, that's all from Samba.
Cool, awesome. I forgot to ask you earlier, but is there anything you would like to show us as a demo, or prefer
Not
to
right now.
experience? All right.
Yeah, not right now. Yeah.
Cool. Yeah, no worries about that. But super cool. So I'm curious, for us kind of people that don't understand the tech as deeply as you. Can you explain briefly like what these Ethereum portals do, and what is the benefit for it, and
So
how you're contributing to that?
Yeah, so one of the main benefits is to decentralize the access to data on Ethereum. So instead of, or originally, because things will be changing and are changing as time goes by, and time as the community decide which path to take, the main idea was to decentralize the access and allow the execution layer to reduce the amount of data they use. So instead of having to persist every information genesis, the idea was, okay, let's stop doing that. Let's have another network that provides the data when needed, and let's avoid overloading the execution layer with this type of data. So the development brings to develop different type of subnetwork, as they are called, in order to address those needs. So that's why there was a historical history subnetwork, a beacon subnetwork, and state subnetwork. The problem is that how can I say? The problem is that all this development hasn't been shifted to production yet, and things have been reshifted. So the main purpose today is to deliver the history subnetwork attached to the execution layer, and this means not having each of the portal node as a standalone solution, but that depends on each of the teams. But actually, the idea is, okay, let's deliver something that could be taken to production, although it might be fully coupled to the execution layer. And let's work on the history, and then let's later decide how things may evolve. So this brings the idea of not having standalone solutions, but having something inside each execution layer, or as a sidecar of the execution layer, and that will bring us the solution easier and faster. So, and the nice thing is that although the whole scope of the portal network is evolving that situation, Samba was designed with this in mind to work as a standalone solution, or embedded in this case in Besu as an execution layer. Although there are certain changes that we will have to take in order to make this adjustment. So you might think, okay, Portal might not be delivered as a whole or as initially as it was originally designed, but it will be, we can reuse what we have been working and put inside the execution layer, adapted to the, in this case, because Samba is in Java, adapted to what Besu needs, and start providing the historical content. And then if time goes by and the community accepts that there's a need for this, the next of the state and beacon subnetwork, things will evolve from that. Yeah, sorry, I took too much time to answer your question. Sorry.
No, good. Thank you. It's good to go deep into these things to understand them better. Appreciate it, Melson. And last but not least, let's hear from Mate about the HEVM.
Yeah, hi everyone. I'm Mate. I work in the Argo Collective, and I help develop HEVM. So HEVM is concrete and symbolic execution framework for EVM bytecode, which means that it works on the execution layer, and it's a tool to both find bugs through fuzzing, as used by Echidna, and also as a tool to find bugs on its own using the so-called symbolic execution system that it's capable of doing, which is basically a way to execute.
Did we lose your audio?
Oh, did you?
Can you hear Mate?
Yes.
Yeah? Oh, sorry. It's
okay, and you can't hear me?
Go on.
Oh, okay. That's good. Yeah, so it's a symbolic execution system that allows you to, instead of running with concrete values like 1, 2, or 3, you can run it with a variable such as A or B, and that should improve the coverage that you can get from just traditional fuzzing. Because if the variable that comes into a function needs to be some specific value that is very difficult to guess for a fuzzer, then HEVM can guess that value, actually compute that value instead of guessing it. Let me try to present. Maybe it will work this time around. So let me try to share my screen. Yes, I think it will work now. No, it won't. Okay, well then, so I can't present a I can't present a visual presentation of what this actually does, but basically what you can do is if you use Forge to build your system, then typically there would be a certain number of test cases that you have for Forge. And these can be tested via the standard Forge test or even fuzz. But HEVM can actually do more. It can run in a mode where it will run your test cases in symbolic mode, where it will try to execute every single potential way to execute your function or different functions in your contract, and therefore discover all possible execution traces and find all the bugs that are technically possible given your set of asserts and requires that you have written in your code. In other words, this is a more thorough execution or test than your normal fuzzing or just normal test case running. So it's effectively a way to have higher assurance of your contract. But because it can give you higher assurance on your contracts, it can also give higher assurance on other contracts as well. So in case you're interested whether, for example, a contract has a hidden mint function, you can try to use HEVM to actually discover this hidden mint functionality, because HEVM will try to execute every single possible way of executing the contract, which means that it will discover every single function, hidden or otherwise, in the contract that you're interested in, and will actually be able to figure out, for example, if you write a test case for it, then it can figure out whether it can mint execute a function in the contract that allows it to mint a certain asset. It can even figure out which address you need to be in order to mint call that functionality, and therefore reveal which potential addresses, for example, have a hidden access to the contract. This is possible because it can execute the contract even though it doesn't have access to the source code, because it runs on the bytecode. So in case the contract is deployed on the blockchain, then of course the bytecode is visible to everyone because the blockchain is public, and therefore we can keep on running it, even though the source code is not available. So it can help understand and examine contracts that are otherwise potentially difficult to examine and understand. So that's the HEVM tool, and the HEVM tool itself is actually made of two parts. There's the library and there's the command line interface. And the command line interface can help you access the symbolic and the concrete execution directly, but the library itself can be used by other tools such as Echidna in order to make use of the tool and build on top of this tool. So we're hoping that with this tool, we are contributing to the system of tooling available in the Ethereum based blockchain systems, so that analysis and therefore assurance is higher, and we can in the long run, more systems can move to this kind of blockchain based, let's say, underlying like blockchain-based system, so that we can actually have like a larger pie. We can sort of grow the pie into a larger pie, but this will not happen unless people have trust and believe in this underlying layer. And we are hoping to improve that trust and assurance through this tooling.
Cool, awesome. Thank you, Mate. And yeah, I've been dropping a couple times, so if I disappear, don't be scared. We have Sarah in the backstage ready to jump in case something happens to my internet. when we do spaces, we tend to blame Elon for them going down, and to be honest, I don't have anybody to blame in this case, so apologize for that. Yeah, thank you. These were great intros. I hope the community learned more deep into what you guys are building. And something that I'm curious to learn about, you all mentioned, let's say, finding bugs or kind of addressing security issues in some way or another. I would love to hear from you, how do you think your different methods differ, or how do they complement each other? I think that would be helpful for us to understand.
That's a great question, actually, because Act is very complementary with HEVM. And in fact, right now, Act, I'm sharing my screen because that might be easier to describe this way. But for this step, currently Act relies on HEVM to do this proof. So this automatic low-level proof of equivalence uses HEVM currently. Because Act is very modular, it could also use other tools, and we plan to integrate other tools in the future. But right now, what we do is that we translate this formal specification into a language that HEVM understands, and then we interface with it to do the formal proof of equivalence.
Okay, very cool. Love that. Now it makes sense why you both are part of the Argo collective. It's clicking in my head.
Yes.
Are there any other interesting synergies with Argo collective that are worth mentioning here?
I mean, maybe I can mention that HEVM, because it's capable of doing equivalence checking as well. Because, well, of course, what you can do is that if you can symbolically execute a contract, that means that you can figure out for every input what kind of a new state it will be at, right? So it's basically the blockchain is a state transition system with some kind of function call that comes from the outside, and it affects some kind of change, like transfer of money or transfer of assets or liquidation, etc. And because it can compute the what's the new state, what it can also do is that if you have two different contracts and you're not exactly sure if the two are behaving equivalently, then you can compute all the way each of them can change the world, and then check if they change the world the same way. And if they change the world the same way for the same input, then they must be equivalent. They must behave equivalently from the outside. Of course, they could have a different gas consumption, but from the behavior perspective, they behave the same. So this means that what you can do is you can actually check for equivalence of two different contracts, which means that, for example, if the Solidity compiler has a bug, then what we could do is run HEVM in on two differently compiled contracts. So the same contract compiled two different ways, and check if they are equivalent. So HEVM can actually help find potential bugs in the Solidity compiler, and the Argo collective also includes the Solidity compiler team. So we can actually help the Solidity compiler find bugs, and we actually do try our best to do exactly that. So it's a versatile tool that complements other tools and can also be a way of checking or improving other tools. Because, of course, this also means that you can potentially add more optimizations into Solidity that previously you were afraid to add. But now with the new, basically, safety harness, you can be sure that the optimization is not incorrect.
Very cool. I love that. A lot of things are clicking in my head with regards to the Argo collective. I want to ask one more question about that. So Melson will be back with you with the question about finding bugs in a bit. But also for the audience who's watching right now, we've seen some comments. Thanks, Jerry, for that cool comment about HEVM. If anyone has questions or anything, feel free to drop it there in the broadcast chat, and we'll make sure to ask them here, or any comments are also more than welcome. So back to the Argot Collective, how did that come about? Like, yeah, in general, just because there's a bunch of teams there, and who came up with the idea, who gathered the Avengers, let's say, who's the Nick Fury of the Argot Collective?
Mate, do you want to take this one, or I can try? I would say
You
that
should try. Go ahead.
there is not just one person, just a synergy of people who are working on languages and tooling. And our main purpose is to make like correct by construction ways to build smart contracts and application on top of the on the Ethereum execution layer. And verifiability is like very high on our priorities. So I would say just we're a group of people with very like similar um, vision for the ecosystem and technical background to achieve this.
Okay, cool. Thank you. Do you have anything to add, Mate? Or
No, I think that's a great way of describing it, and yeah, I'm very glad to be part of it. And yeah, it's a great set of themes that I think fit well together, and we can complement each other, help each other achieve this common vision of making Ethereum based blockchains grow faster and be safe and be trustworthy.
amazing. And are more teams joining, or is it open, or like how do you screen for that? Or right now you're pretty much set with a set of projects that are part of the Ergot Collective? If you know about it, because you might not know.
For now, we are set on like the teams that are the people and projects that are part of it. But we are interested like in expanding our projects and like start new projects that we think are aligned with our mission.
Okay, awesome. Thank you for that. And Nelson, back to you about you did mention also finding these kind of bugs and these security issues. Is there anything you'd like to add about how your tool complements to that or differs from it? I know it's not maybe the main focus, but still curious to
Yeah,
hear.
yeah, yeah. So yeah, as you mentioned, it's not our main focus, but our approach is this idea of our need of reusing things that are already deployed and being used by other teams in other situations. What happened to us is that our goal is to make this as simple as possible. So we are trying to reuse things. So, and this brings us not as a natural process of trying to reshape what is already built and address the needs we have. So in that process, we come to situations where we need to use certain libraries or request changes to certain libraries, and this happens sometimes, that bring us or that let us discover that if we use things in another way, or we start using things that are being deployed there but is not being used so frequently, we happen to find bugs. You see, so this happened, for example, when we need to use, for example, the DSP file library for updating a node record. We found that there was some concurrency issue there when updating a node record, that there was something that wasn't widely used. But we need to follow the specs, and under that direction, we come to find bugs because we use those libraries in our ways. So it's, yeah, our process of finding bugs is not the main goal. It's a consequence of reusing things for addressing our needs, but by reshaping what is already being developed. Yeah, that's nice about this. So we yeah.
Cool, thank you, Melson. And you did mention the next topic I want to talk about is sort of like the Ethereum vision related to your project, and you did mention, Melson, that there might have been some kind of conflicting visions about Ethereum between like when you started and now, and like how that affected your project. Do you want to talk a little bit about that? Like, what is the Ethereum vision that you um, subscribe to, and how is it maybe like a little bit different than what it is now, and like what are you doing to get to that point?
Yeah, sure. So I'm not talking on behalf of Ethereum. I'm talking on behalf of a contributor that started project last year and following and developing a node, in this case, Samba. So originally the idea was to have different subnetworks for providing data through each of these networks. So you have the history, you have the state, you have the beacon subnetwork. And since June, there was a shift on that direction. The reasons because of that, I'm not fully aware, but there was a reshift. And my opinion is that the project was too big to deploy something fast, and things were more aligned to deploy something smaller and try it and see if it works. And because, as you know, this is in the past to be validated, to be adopted, and it's a possible solution out of other ones to address the content distribution inside Ethereum. So under that circumstances, in June, the whole roadmap was reshifted, or during June, the whole roadmap was reshifted, and the idea was the way I think it, you see, is that let's deliver something smaller, but let's deliver something that we can start using, and the execution layer can start using and validate if this is a solution we are willing to adopt. So under that circumstances, the decision was to, okay, let's stick with the state, the history subnetwork, that is the subnetwork that we have started developing last year. And let's change certain stuff and let make it work inside an execution layer and not as a standalone solution. The good thing is that, as I mentioned, Samba was designed from scratch with that vision. And that brings us extra cost because in terms of developing, because we always thought of having Samba as a standalone solution. And with this, I mean, let's have a node that you can deploy individually and not attach it to execution layer. And at the same time, let reshape or considering the design being able to deploy this inside the execution layer. That in case the execution layer node is Besu, that is also in, in Java. So the idea of this new roadmap is to reduce the scope and stick to the history subnetwork and make it work inside the execution layer. So there are things that are changing, specs that are changing. So the idea will be to reshape the node in that direction, and at the same time evaluate if the community is willing to accept this. And maybe in the next couple of months, we are reshaping this again in another direction and reusing what we have for this new goal. I don't know, Nico, if I answered your question completely, or if you have something more to ask about this reshape of the role.
No, that was great. A lot clearer now, and yeah, really looking forward to see what you guys are shipping to bring that vision to life. Also, thank you, Jerry. Big shout out to you. Very active community member and contributor of Octant, always sending good questions. And I think this is a question maybe related to what I asked, but maybe for the HEVM and ACT teams. How long will these debugging, verification, security tooling be needed to be aptly added into an aggregated tool game? Is there one? Or
I
Mate,
mean, maybe
go
I
for
can
it.
have a go at it just for a moment. I think, in general, I think it's a good idea to have sort of this um, sort of a place for ideas to grow and work together with each other, and also, of course, compete with each other. So I don't think there is a place where I feel like it's done. I think humans tend to be quite creative and come up with new ways of doing things and more thorough ways of doing things and verifying even more of what's out there. Um, this is also partially related to this question of what is a bug, right? Because a bug could be, oh, I can drain your contract, but there are more complicated and maybe even more interesting ways of defining what a bug is. You could say a bug is something that is an unintended consequence that nobody would, or most people would not anticipate, and then the verification tools would need to be more complicated and maybe even incorporate things like unanticipated hike in interest rates. And could that happen? Can somebody force the system to create such an unanticipated hike in interest rates, which is not what I think most people would consider as a verification issue originally. But once you show them that there are indeed ways of doing this kind of manipulation, then they might consider that to be an actual bug. So I think in I yeah, I think it's important to keep an open mind about what we are verifying and what we're capable of providing assurance for. And if that is the case, then I think there's always going to be more and more things to be able to provide assurance for. And so I hope it's in some sense never ending. But of course, we always provide more and more assurance and capable of doing more and more. That's my take on it, I think. Yeah, maybe others.
Yeah, no, that was great. Zoe, do you wanna answer this question, or if not, we can also answer like similar to what I asked to Melton about the vision that you see for Ethereum related to Act.
Yeah, kind of related questions, because while I think it's an open-ended like space, and we can keep adding on and keep adding capabilities and like make things faster, make things more scalable, more automatic, more expressive in the like in the logic and what properties these tools can express. But the vision is that verification is like a standard practice, is like a part of the development process of the life cycle of software. So the goal for, I would say, both tools is to make them part of the software development process of smart contract development. That would be the end goal. And we can, of course, keep adding on and make them more powerful, more modular, more versatile. But the vision is to have them be used.
I think you're muted, Nico, actually.
No. Oh, I think there's massive delay. Can you hear me well? Okay, cool. Sorry about that. So my question was like, what is the most exciting breakthrough that you've had with your project? Melson, do you want to start?
Okay, let me think a bit about it. Maybe other one can start. What I think. Sorry. Okay.
Yeah,
I
if
can
anyone has one.
go.
Zoe?
So for Act, the most exciting breakthrough for us was the ability to connect the model of the software with the actual implementation of the software. While there are tools that let you reason about transition systems, there is the gap, and the gap is that the model of the software is not guaranteed to be a model of the software. And this is where ACT comes in. And like, we want to be this glue that gives you a formal tie between the model, the state transition system that describes what the contract is doing, and the actual bytecode that runs on chain. And that for us is what makes ACT unique and powerful.
Cool.
The
Yeah, no,
ability
that's
to do
amazing.
end-to-end proofs.
Amazing. Mate or Melson, whoever has.
Yeah, go ahead, Nelson.
Okay, so from us, is this idea of, how can I say, this idea of building a novel solution by reusing things that are designed to work in certain situations and for certain goals, but when you have a clear goal, you can, this idea of reshaping things, reshaping what is already built, these building blocks, and mix it and do something completely different with that technology. So actually, an example is, okay, let's use this file, this discovery library, but let's mix it with UTP and use a special message that is a talk to share content. So this idea of, okay, reorganizing certain building blocks and provide a new solution. I would say that, yeah.
Nice.
Maybe I'll go ahead then,
Mate?
just for very quickly. Yes. I think actually there are two things. One of them is that I think it's a breakthrough from the perspective of what we want to achieve, which is to say that we want this tooling to be actually used on a day-to-day basis by people. So we want this tool not to be, separated out into some little corner, but to make the tool actually useful and usable. So that has been kind of the breakthrough. We have made the system significantly more stable and user friendly. So it's much more easy to engage with it and use it every day, which is our hope that it will be used more and more by more systems. And related to this, being in a sense being used is that we have actually managed to convince Echidna to take full advantage of HEVM, and soon there will be a release in Echidna that will actually take advantage of the symbolic execution framework inside HEVM, as well as the concrete execution which they're currently using, so that it will be basically automatically used if you're using Echidna, which is great because that means that we reach more users and there's a higher usage of the tool and more benefit to the entire ecosystem from the work that we have done. And it also means that others also consider HEVM to be a significant, important, and stable and robust tooling to actually perform this work. So that's I would say a great achievement from the perspective of actually reaching the users and making users take advantage of the work we have done.
Cool, thank you. Can you hear me? Is it good? Yeah. All right. Cool. So thanks. To wrap up, because we're almost at the top of the hour, I wanted to give you the opportunity, maybe developers, contributors, or anything, or maybe share some cool updates you're excited about. It's just free for you to take these couple minutes. So So Zoe,
Okay, sorry.
So thank you, Nico,
you want to
for
start?
giving us this opportunity. It was really great to discuss, first of all. And then I want to share like some details about the future directions of ACT. We are very excited about like a number of directions that we can take in the future. And one of them is being able to automatically decompile EVM bytecode into the specification, so the user wouldn't have to write the specification. The specification would be synthesized automatically, and then we can use the nice tools that we have that we connect with to do the verification. So we are very excited about this direction. We are also, so this, we think of that as this versatile intermediate layer between low-level bytecode and high-level verification tools, and it's very like modular, and we can plug things and tools. So we want to keep adding on this like tooling to be able to add more verification backends. Like currently there is work in the team for adding a economic analysis framework for analyzing contracts as protocols, and we can reason about game theoretic security of contracts and more. We want to add an interface with a lien proof assistant to be able to reason about like the contract specification in the lien proof assistant, and sky's the limit. Like I believe that it's a powerful and modular tool that can let us express and verify many different things.
Thank you, Zoe. Melson, wanna go next?
Yeah. So in our case, our updates are more around how we reshape what we have right now to address the new specs, and how we also adapt our solution to be fully integrated with Besu, but at the same time leave the door open for the future changes if things are decided to return to building the other subnetworks. So actually, it's a challenging decision where we need to be able to show that the solution can be fully can be working with Besu, and at the same time be flexible enough to add the other subnetworks in case in the future that is decided to do.
Nice, thank you. And last but not least, Mate.
Yeah, hi. Yeah, thanks a lot again for this opportunity. It's been great to be able to talk about the tool that is so close to my heart. And of course, it was great to hear both Mount's and Zoe's presentations as well. What am I excited about? I mean, this week we'll get a release of a new release of HEVM, so that's very exciting for me. It's been a long time coming, and we have a very long change log that I'm very happy about. So it's been a lot of improvements that will go into the final release that I'm super excited about. And with this new release, hopefully we will also allow Echidna to finally enable the symbolic execution in their release. So what I'm really excited about is more people being effectively, without even knowing about it, being offered a new way and a more powerful way of finding bugs in their contracts automatically, effectively, if they're already using the Echidna framework, which many do. So I'm very excited for a lot of feedback that we'll get from different parties in this ecosystem who take advantage of our tooling, whether they know it or not. And so I'm excited for all the interesting ways people will take advantage of the tooling that will hopefully be in the next couple of weeks or months we'll hear about.
Cool, amazing. Thank you, everybody, for your working on these amazing projects and contributing to Ethereum in such a deep way. I think the entire community really appreciate it, or although you cannot see it sometimes and might not feel like that since you're really in the background. But it's yeah, you're really helping with the foundation of everything. So really appreciate that. Thank you for coming by. And encourage everybody to vote for these projects, allocate your rewards on Octant, that app. And yeah, thanks everyone for coming on and listening as well. And Jerry, for your cool question as well. And yeah, without anything else to say, I'll just say goodbye to everybody and thanks again.